Alright, hi everyone. This will be a bit more calm than the usual 1 minute hysterical YouTube shorts. And we also had a mad shooting in Sweden recently, so we are affected by that, and madness is everywhere currently. But I'm not going to go into that further, so let's just do something that is joyful and peaceful. So let's go into the Subreal, shall we? So what we have here is all the parameters that you can reach by combining these in this one in 4 positions and this one in 4 positions. So if you do that, you get the combination of 16 slots. Now, if I just now start the playhead and I load the demo project that is available here to just let's see that we are. Oh, it's haven't. Here we go. So now it has started the synth, and I will walk you through all the parameters so you understand what they do. So now we are in first bang, so you can see the mix. And the first thing that you need to know is that the oscillators aren't like a mini Moog. They are wavetables that you can send a recipe to them. So here you have the endpoint for doing that. So I can send an endpoint to the wavetable that this should be, if I can listen to only the first one. Now I just want a sine and nothing but a sine. I say like that. It didn't work very well, did it? Aha, it's because we are still modulating. So here we have it. Here we have it. Yeah, you saw the modulation there, right? So here we have only the sine. And let's say I want, I don't want the, what do you say, bass frequency. I want the double frequency. So that's the sine of the double frequency, right? And normally a square wave or a sine wave, as a sawtooth or anything, they are built up of overtones. And the reason that I don't do the in caustic, you can draw the waveform, but what you do then is that you can create really nasty overtones. So I don't want to do that. Instead we have this like recipe where you can say that you want, for example, you want, and it normalizes, so you can press like 1 and 0.5 and 0.3 and 0.2, and then you get, a wave that is a bit more like a saw. We can add a bit of a salt to it, like. So now we get like an FM modulation, even though it's just one oscillator. And then we have the second oscillator. So that's the mix here. So I can go, this is the first oscillator only, and then it's the second oscillator. So instead of using this loop 1 overtones, I go with loop 2 overtones, and it's the same thing, right? So if I only select the first here, I will now get a sine, just a sine. And what's happening behind the scenes here is that, all the factory, as I do this request, the factory will create like a sample of 64 kilo samples, and then we'll create that on the heap and store it in a queue, and the audio thread will pick it up and start to use it. So we can just do like this. So there we have our second oscillator, and here we have our first oscillator, right? But we also have the ability to do frequency modulation by letting the second second oscillator modulate the first one. And that is because we can also control this frequency modulation with an LFO or with not with an envelope though, because if it was an envelope, then we are approaching what would be like an FM synth. So that would be the next step to build the FM synth, and I think that can be a fun way to do, like in a workshop together, building that FM synth where you have the frequency modulations through envelopes. A bit more advanced than the FM synth in Caustic, but you know, the same principle. But here it's just shaping the tone without envelopes. And here, this one is the D tune for oscillator 1. And here is the octave for oscillator 2. And you can see you have all these, here you can see the first one is the mix, right? The FM sensitivity, the detune. And now the octave, the semi, and the detune for oscillator 2. And you can hear a kind of lame attack, right? So if we go down here, this is the first, second, third, fourth, fifth, sixth, seventh. So with at the output of the synth, right? So we need to go to the seventh bank. So that's here, right? Now I can, that's the attack, and I can play with get down the release. So, but let's go back to take it in order, right? So we did this, and now we go to the second bank. Here we have the cutoff. So the first thing is that this one, I actually did that. This is by default in off, so there's no filter. So these do nothing, and that's partly because you can shape the tone first using frequency modulations and the overtones, and then you apply the filter. So you have that like an extra step, because it's also a bit computational expensive to do the filter. But let's enable it. So now we have a low pass filter, right? So here we have the cutoff and the resonance, and here we can have a steeper filter. No, not steeper filter, sorry. So here is the low pass, band pass, or if it's this is the band pass. So this is the high pass. And here we have the steepness of the filter. So we have 12 decibels per octave, or 2-pole filter, and here then it's 4-pole filter. So here you can have the 2-pole filter running, and here's the 4-pole filter, and then you can invert. So it's the same filter really, but it uses the envelope differently. So instead of the envelope addressing the cutoff, opening the filter as the envelope goes up, it closes the filter. So, or actually, you are inversing the signal of the envelope. So the envelope is up in the sky when you from the start, and then when you press a note, it instead of the envelope rising, it decays to 0 on backup later. So we can try that, and that can, having that inverse envelope can be really effective when you're doing like bass sounds and stuff like that. If you played with analog synths before, you know that inverting the filter can be really effective, and if you play with a synth that doesn't have that ability, it really leaves you out a lot of possibilities. So that's the like this this is the cutoff, the resonance. Here is the cutoff keyboard tracking, and I guess you can understand what that is, right? We had that in Caustic too, but the sad thing that was that Caustic I think he did it in the bad way, because Caustic opened up the filter on the treble and closed it in the bass. And I often think it should be the opposite, right? Because you don't want it too screamy in the treble, but when you go down in the bass, you want to open the filter so you get the harmonics. So let's try that. So we have the we can take down, and we go down a bit. Let's see with the hmm. Yeah, here you can hear it clearly in treble, right? So if I here I open up for the treble, and here I close for the treble. So that's a nice way that you can make treble less squeaky through that. And you also have the same thing with the velocity, and I try to make these have them constantly in this way that you have the keyboard tracking, and then below that you have the velocity tracking. So here it's the same thing, right? So, and I think you can do the other way. Yeah, so you it's a bit odd, but you can have the filter being fully open on low, and as you press it harder, so that's, I guess this is more normal. And let's play with this, because I think what I think we need to get some overtones. So here we open up the overtones, right? Yeah. Okay, so that's that. You have the cutoff resonance and the cutoff keyboard tracking. The type, which is either band pass or low pass, high pass, or band pass. It starts with off, really. And the shape, which is 2-pole, 4-pole, 2-pole inverse, 4-pole inverse. And then the cutoff for the velocity frequency. And now we are at the pitch envelope. And that's fun too. You can do like we need to have a bit let's get it, just remove the filter, right? You can hear it, right? Yeah, okay. And the same with the release. So you can come and you can go down like this. And we need to have some kind of release. So once again, we have to go to bank 7 to fix with VCA. Yeah. This isn't really working, is it? There's something fishy going on here. Interesting. Yeah, it works. And the thing is that you have the time for the attack, the time for the release. And here's a fun thing, and that you can affect the width of the pitch bend wheel. So that's normally just 2 semitones, right? but you can ramp it up to 12 semitones or anything there between, you know. Um, so that's fun. And then you have something called noise, and I am playing with that. I'm not totally satisfied with it, but you can hear it. I just reset these now, and I can also fix the. I'm sorry. Here we are. Okay, so I'm not totally fine with the noise, but I can show you what it is. What it does when I dial it anti-clockwise, it will produce a noise during the slope of the pitch envelope's attack phase. So if this is really long, you can hear that it kind of long noise attack. And there's something funny with that too. You can hear it sometimes it pops away in a way that I don't really like. So that's something funny there. Anyhow, that's when you dial it anti-clockwise. And when you deal it clockwise, like this, you need to have an active filter. So we need to bring in the low-pass filter again. Because now the noise is kind of melting into the filter. So why doesn't it work? Why doesn't it work? It should work. We go to the This is so embarrassing. There should be noise here now, but for some reason it isn't. But the idea here is that there should be noise. But let's do this. Let's go in and check why there is no noise. So we are playing with the Subreal, right? So we can go into the source here. And I hope you find this a bit amusing. So this is not the core. This is in the synth folder. Not the assets though, because we are looking at the code. And the synths, any polyphonic synth normally has the model, which is like the motherboard, and then the voice card. So the motherboard receives the parameters and may do stuff with them. So we can look at that first. So here we have probably here some noise, yeah. So we have the noise. So if V, here we can set how these parameters should play. That it should be by default in mid position 0.5, and that the minimum value is -1 and a maximum value is 1. And it's not logarithmic. It should be distributed linearly, and it's always returned in V. This comment is just bad. So if V is positive, that means we are dialing it this way. We are affecting the noise, and in the VCF, and the noise in the oscillator 2 should be 0, because that was the puff you heard earlier. And if it's negative, then you know you should have the noise distributed to oscillator 2 instead. So, but obviously something here is not working, and then you know, for any voice, since this is a polyphonic synth, the actual thing happens here in the voice card. So let's see what happens. Why doesn't this? If something, when we are doing the filter, then there is something not working here. And what is that? What is that? We have to look in the filter. The filter are in the core audio, and these are like templates. Of course, you might do your own stuff, but this is a template um, for DSP units. So here you have something called noise level, process block noise level. Okay, so fine. So did we use that in the process block? Noise VCF. So why doesn't that noise VCF? Yeah, we are doing everything right here. We pass this value into the filter as we process it. So let's look at that again. Noise level. Could be that we need to store the noise level. Here I see something that might be a bit that we don't use it when we are doing the 4-pole filter. Do you see that? So here we are calculating stuff for the 2-pole filter, but not for the 4-pole filter. So let's try that. We take down the filter to a 2-pole filters, which is here. So is that true? Yeah, it should be. And now we try it again. Yeah, there it is. So there we had it, right? So we didn't use this stuff that we're doing here. We're not doing that. And to be honest, I'm just taking a wild guess on how this is supposed to work, because you can do this filter noise in the I think it's in the what's the synth called? I think it's a Howard Jones synth. I don't remember. But I don't actually know how to do this stuff, so I'm taking a guess here, really, just. But we can do that anyway. We just do this. We are playing with D2 here, so let's do the same thing here. We're playing with D2 there, and then we are stopping this. And now we need to recompile, obviously, and it will take a while, but not too bad. And as it recompiles, we can go back to our CC mapping and look here again. So we were at noise here, right? So let's see if we can wake it up. Come on! So for some reason it takes a bit longer when you launch it through the code editor. Here we go. Oops. Here we are. So load the demo project. Here we go. Yeps, and we can just load a patch, be a little bit lazy here. And we take this, the filter and set it. And now we should have the filter for both the 4-pole and the 2-pole. Yeah, it works. It works. Whoa, yeah. I think that's something funny when we use the filter, because it kind of overdrives the signal. So yeah, there's something there that we need to look into. But let's take down the filter a bit. And maybe we should not stress. Funky. All right, so we have the filter and it really works now. And so the last position in this first, this is the master, and you can call this the sub chooser, is the LFO. And the LFO is fun because you have a ramp also, which I think is really nice to have. So the ramp is here. So so you have the frequency, right? And you have the depth. Oh. It just killed it. Haha. And here we have the waveform, so you can start with the sine, right? And you have the routing, which we route to both oscillators. So here it's off. Route to both oscillators, or route to one of the oscillators. So I think it's for normal, you want to route it to both oscillators. We can go back to the first one, and you can just here you have the mix here, right? And we set some to tune. And then you have the ramp, so you should have the ramp here. It took a while, right? But if you don't want, maybe that should be the other way around, right? Because when you max it, you don't get any ramp. And that thing is for like instruments where you just want to have you want a sine, and you want just a tint of oscillation. So and you want this to not start from the beginning. There's the filter, not the noise. I mean, you can take away the noise. I think it's also funny because when you add polyphony to it, the noise just takes up more and more headroom. It doesn't make sense. That should be in a way monophonic, I think. Yeah, I'm not happy with the noise. Just so you know that. Okay, so here we go. We continue our journey with the Subreal, because now we are entering some really fun stuff in order to make the Subreal really playable, and that is to have the keyboard tracking and velocity tracking too. Because if we go back to the first slot again, you might remember that we have the mix here, right? So we have, whoops, I don't know what happened. For some reason it's just dead silent. Sorry, can I load the patch? Yeah, okay, fine. We go back to the first parameter, and here we have the first oscillator, and here we have the second, right? We can, we're fine with that, right? And what we can do now, by going this way, now we are at fifth, so now we are here, the fifth bank of parameters. So we have the mix keyboard tracking So if I now, if I go up a bit, oh, mind your ears, right? This might be enough. Let's go back and just listen to it. So maybe we want to take away that aggressive. So we want to go in this direction as we go up. So we can do that. So now we are back at the mix keyboard tracking. So this is now the control to. So by doing this, we are now using second oscillator more as we go up. And we can also do the same with the velocity. So as you can see here, this is oscillator mix keyboard tracking, and the fourth one, so 1, 2, 3, fourth, is the oscillator mix velocity tracking. So let's say I want to, when I press harder, or I can go the other way. And we can go down like this, and here we should have, we can reset this once, so you can hear just by this one. So now we have more of the oscillator 1. Now this is also the bass is driven by oscillator 2 more, so there is no harmonics. So we can go back and have some more frequency modulation. Right? But even if we have more frequency modulation now, and we go back to the fifth, and of course we want visual stuff for this, we want the front end, right? Definitely. But if we now go up, it's still quite okay, right? So if I remove this, I get this kind of. It's still a bit too much, so maybe we should lower it a bit like that. And now we can actually increase it, because when we increase it here, it will increase that in the bass. I wonder if that. Okay, and we have those for the mix. And we also have the same thing for the frequency modulation. So here we can. So we push the frequency modulation, not only the mix, but also the frequency modulation. So increase it when we go down, and decrease it as we go up. Instead, if we increase it as we go up, it's hard to hear, but now you hear it, right? Still some click and noise for me. I thought I had it gone, but there's still some click. And we have the, can take away. Okay, so we have that kind of way to manipulate the voice with keyboard tracking and velocity tracking. And the pan, of course, that is a fun thing to play with, because then that gives you the stereo. So as we are in the bass now, it will push the voice to the left, and as you go up, it will push the voice to the right. And this is, one of those moments that you really want to have headphones, and you also want a bigger keyboard, not just this tiny little stupid keyboard. Okay, and the one that you haven't mentioned is super awkward, and that where you start to make more funky sounds. And this is the one. So we can start by just using oscillator 2, and we go back and listen to what happens if I drive down oscillator 2 frequency tracking to the bottom. Yeah, I get some voice leak from oscillator 1 because I have this tracking stuff, but I can remove those. That should be the mix that affects. I can take that one too. So you hear, right? It's just no tracking. It doesn't follow. And if I just and I can go. Here is the normal thing, and I can go above that. Hang on. Yeah, there. So. And if you combine that with, having a first oscillator and modulating that first normal oscillator with this awkward second oscillator, maybe not so much modulation. Back and what if we use the fixed one? Yeah, you get it. Let's go back to the one. And here you have the envelopes. So you have the attack, decay, sustain, release, and fade. Fade, I've mentioned that before, but fade is about leak. So if we go to the VCA, you have a small leak there on that one, right? So we can maximize that leak. So that's really maximized, and now there's no leak. And that's the same for the VCF. So the VCF is here, obviously. And we didn't turn that on, so we need to start. So we have the, and this is where you want to have, if you, for example, have, this is now when you want to have your envelope, your filter inversed, because we will now go back to the filter and inverse that. Yeah, you can hear it, right? And the normal envelope for the VCA, and then finally the LFO. And one thing I didn't mention with the LFO, as also is for the first one, is that you can choose to have let's go back and just, you know, so you can have the LFOs routed through the modulation wheel. So how that works is that you choose, should this, this has actually I think it's three positions. Either it's off, or you route the modulation which affects the speed or the depth. I think depth is actually the first. So let's try that. We go to the oscillator 1. Here we are. Okay. And if we want to use this modulation wheel to affect the depth, this one, now it does nothing. If we are here, and if we take it here instead, we affect the speed, right? So we can have a really high speed. And we can do the same with oscillator LFO 2. So we go here instead, and they say this one should, this one, right? And we should affect the depth with this. And we have the sine, and we have the square. And you can hear the ticks. It shouldn't be there, right? You can hear this sawtooth. And I have sample and hold. Yeah, you can hear it. So there you have it. There you have all the parameters, and there's actually one not used. So if you guys can come up with something to use that parameter for, that's fun. That's the reward for watching this pretty boring video. Okay, have a good night everyone. See you.